This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Good afternoon. We discussed, for those who attended the MOVA user group yesterday, the first application of MOVA in Cyprus. Today we will talk about the new UTC system in Cyprus. So we had a UTC, we are replacing it with a new one. Just a couple of bits of information about Cyprus. The project, it's going to be implemented in the capital of Nicosia and the coastal city of Limassol. The other two cities in Larnaca and Paphos, we did traffic studies the last 5 years for all cities, and we applied other solutions. We did some reconfiguration of the signals in the cities of Larnaca and Paphos, but Limassol and Nicosia have traffic problems that need solving. So the need is to improve traffic conditions and road safety in both cities. You can see on the right side that we are under 1 million people, but we have almost the same amount of cars. So we need to keep these cars moving efficiently and safely. The bus system and the pedestrian and bicycling use is not that high, so we ended up having to improve the traffic conditions. We are looking into providing adaptive control and bus priority on the model of other UTCs in Europe and the UK. We drive the same as in the UK, and our standards are the same as in the UK, being a British colony in the past, so we use a lot of the solutions you have here. Along with the new UTC, we will renovate and upgrade the existing school control center, which is based in Nicosia. This project is fully funded from the European Commission, from the Thalia Fund. It's around £8 million. We had a SCOOT running from 1992 to 2017, so we had 25 good years of using SCOOT in the three cities, Nicosia, Limassol, and Larnaca. We kept a few corridors in Nicosia until last year. We pulled the plug off last year for various issues, including the TC12, extremely expensive telecommunications. So we need a new system. In regards to the other cities, as we will see later, we will connect the signals, especially the ones we recently replaced, with onto the UTC. So the project has 125 sites, 75 in Nicosia and 50 in Limassol. Some of the controllers are already been replaced, so we only need 55 new ones. We are going to integrate 65 Pelican crossings into this project. It also includes, in all locations, sensors, outstation units, the routers, all the signal equipment, cabling, and there are some existing controllers that will be connected. Those are primarily Siemens ST750s and ST950s. As well as some PIC. I saw Ferrandi mentioned in the previous presentation. We still have 2 Ferrandi running from 1985 and a few T200s. So 40-year-old controllers are still running, though we are not planning to include them in this project. As well as the controller replacement, we will install environmental stations. We'll discuss it a bit later. So it's a typical UTC, including telecommunications that will go on cloud. So everything will be on cloud except the local equipment in the control room. It includes works on site, the use of the portable signals for each replacement, traffic safety measures, the trenching. I will discuss a bit the use of technology we would like to use, having used the loops, the scoot loops in the past, and how with the new technology we are shifting into radar and video detection. Besides the traffic signal equipment, we are at the moment upgrading our traffic management control center equipment. So along with the signals, we will connect the traffic counters and the weight motion systems, the Bluetooth detection for travel time we have a parallel platform from Svarco, the Omnia Mystic platform, that we have everything else connected except the signals. But we plan to integrate and use with the new UTC how also the traffic management. In terms of signals, Cyprus is small, but we do have 380 signalized junctions and 365 pelican crossings. You'll see from the maps I will show later that the signals are quite dense, so that's a challenge to any UTC systems. So just a brief, some information about the architecture in regards to the UTC. We'll use optimal control strategies at the higher level and traffic signal control actuated at an intersection level. 2 minutes optimization at an intersection level, repeated every 3 seconds. So this was the recommendation from our consultants. We designed this project based on other existing technology, as well as the outstation unit equipment that have to communicate with and cooperate for the computation of the local strategies. And this is in a schematic how it's going to work, or we're hoping to operate it. So it's in terms of intersection control at the local level, at the intersection level, we have the control of the signal groups and the signal plans and phases. The adaptive control is something that we are asking for a big percentage of the signals in both the cities because of the bus corridors that are going to be implemented very soon. And we have the plan selection via the outstation units, so the software to apply control strategies based on demands for the bus priority and the status of nearby intersections. So this is the UTC architecture with the 4 cities being connected, the adaptive in the 2 cities, the connection with the police, the 112 system, and the health, the ambulance services, the local control center, and then all the other facilities that come along with the UTC, such as the fault management system, the environmental stations, and other facilities. So this is the scope for Nicosia. You can see the locations are starting from in one corridor outside the city and then getting into the city center. Nicosia is divided since 1974, so it stops where the walled city is. And that's another challenge we face because we have some arterials getting into the city and they don't continue. There's no ring roads inside the city center area. So we have a lot of problems in the east-west directions. You'll see that Limassol is a completely different story. We have the coastal road and then the parallel roads leading to the highway in the very top. And this is mostly focused on the bus corridors that are coming on the coastal road and some of the arterials leading from the north to the coastal area. We're also connecting the new marina, the Limassol marina area that's becoming very popular and very busy. And all the signals are very densely populated. The coastal road has another challenge that has at least 24 pelican crossings in between the signals, so that's a big challenge for how to provide smoother traffic conditions. And they just installed speed red light cameras on the coastal road, so that's another challenge we're facing. This is the control room, small according to our standards, basic systems. Talking about security before, the police wanted to build walls and remove all the windows. For security, we are adding anti-vandalism glass. Once they realize that the signals don't have sensitive information and everything will be on the cloud, there's no need to go to more expenses. Other services, we will have training, we will have presence of the company who will design and implement the UTC for 3 months in Cyprus, so that's an appealing task for whoever wins this project. 5-year maintenance, we have the traffic data collection and the site surveys and validation included. And we already are in cooperation with the police services, the ambulance, the fire department, and the public transport companies. The public transport is privatized in Cyprus, and they're using bus telematics as well. The platform for the UTC will include the basic data collection, data processing, operation and management for managing the infrastructure and services, and the presentation for the interfaces and the publication of the data and the interaction with the system. The functionalities, again, typical UTC functionalities of managing the basic infrastructure, the bus priority that I mentioned before, decision support systems, the key performance indexes, and the traffic and operation reports, the communications management, and remote demand activation for the traffic controllers of the ones that we won't have the adaptive solution. Some more functionalities of the UTC as is being designed. Again, this is based on existing UTC systems elsewhere. The adaptive control and the traffic operation modes, typical manual prefixed signal phase times, actuated, the timetable traffic plan library selection, and the dynamic traffic plan selection. We plan to employ qualified traffic operators in order to manage the project at an operation level. As I mentioned before, the adaptive will be at least for the 50% of the controllers in Nicosia and 80% in Limassol, and the rest will work on dynamic traffic plans. The environmental data and the sensors we're installing 3 in Nicosia, 3 in Limassol. Nicosia has a serious problem with air quality, so it's something that we want to look into. Besides the traffic improvement and the safety, we'll look into the environmental conditions. The detection, as I mentioned before, video-based and radar-based, the data to be collected will be including speed, volume, and lane occupancy and vehicle length. The public transport priority, again, in order to facilitate the bus priority. So the benefits are based again on other applications around the world. This is what the minister is advertising and promoting. We're hoping to achieve some of these benefits. I know Scoot in the first 15, 20 years achieved a lot of these benefits. I will emphasize more the reduction of delays and the travel time, because it's a small network, it's a small country. The distances are not too big, but the time is important, and it's something that people don't accept easily, as well as the reduction of emissions and other environmental factors, improving the air quality. Reduction of aggressive driving behavior, I'm not so sure. Drivers in Cyprus are very aggressive, especially in the coastal areas, but we have a serious issue with red light running. After we installed 90 cameras on controlling red light, it seems that it's something that we need to work on. So we're hoping that's another challenge of the UTC to manage. So thank you very much.
Thank you very much indeed, Alexis. Any questions? One from me, and obviously my interest in pollution. How did you actually estimate your benefits to the emissions?
The benefits are based on literature and review of other. In actual calculation, we have to see where we're actually started doing some before studies, so including traffic flow or speeds or travel times, and then we will evaluate afterwards, once the system is up and running in both cities, how this is improved in terms of the travel times. Some other benefits I know is not that easy to estimate, and this is something that people ask. The percentages seem too high, but it's something that other cities have seen. UTCs are implemented in many countries, and the benefits are there. It's just they're not so measurable, I know.
Yeah, because of course, Chris's approach, where they got lots of data coming from Scoot, there's quite a lot of potential to use traffic data with the congestion, so you can get a fairly good estimate of the emissions.
Yes.
Including congested-related emissions as well.
Right.
Okay. Any other questions? In which case, thank you very much, and we will move on to the next.